Today we are going to look at conservation of mechanical energy. Let's first define the term mechanical energy. The term mechanical energy means the sum of potential and kinetic energy. We know that kinetic energy is the energy that a moving object has by virtue of its motion, and you can calculate kinetic energy as mass times speed squared divided by 2. Gravitational potential energy, on the other hand, is by virtue of the mass of an object in a certain location in the gravitational field of another object. It's calculated by mass times acceleration due to gravity, which is g, times the height h. The value of h represents the height of the object from the zero potential energy reference. In any given problem, usually the lowest level is taken as the reference level for the zero potential energy. Okay. So potential energy can be calculated by this formula. So conservation of mechanical energy states that potential energy plus kinetic energy will always stay the same provided there are no non-conservative forces. What are non-conservative forces? Forces like friction and air resistance are non-conservative forces. When these forces act on the object, energy is dissipated as heat. So if these forces are not present, then within the system, as something in the system changes, potential can be converted to kinetic or kinetic can be converted to potential, but the sum always stays the same. One such example is depicted in this diagram. As the skateboarder goes up the slope or goes up the ramp, he starts with a certain speed here, and he is at the lowest level, which we can term as the zero potential energy reference. So relative to this level, since he is going up, he will be gaining potential energy. And if he gains potential energy, this is going to be at the expense of losing kinetic energy. So as he keeps going up, say if he gains 100 joules of potential energy, that means he must have lost 100 joules of kinetic energy. So we can always set up an equation where potential plus kinetic energy always stays the same, and we can use that to calculate his speed at any point on the ramp. So let's try and calculate the speed at position 2. So how do we set up the equation? So we know that potential plus kinetic at position 1 is the same as the potential plus kinetic at position 2. So I'm going to write mgh plus mv squared over 2 at position 1 equals mgh plus mv squared over 2 at position 2. Notice that since the term m appears in each one of the terms on both sides of the equation, you can cancel it out. But we are just going to substitute this once. So substituting, we will have 60 times 9.8 at position 1. This is our reference level, so the height is 0, so therefore this is 0. Plus 60 times the speed is given to us as 8 squared divided by 2 equals, when we get to position 2, the height here is given as 1 meter. So 60 times 9.8 times 1 meter plus 60 times the speed is what we want to calculate here. So that is our unknown. So 60 times v squared divided by 2. Now anything times 0 is 0. So this whole thing becomes 0. Now I'm now going to cancel the 60 everywhere. So we don't have to factor that in. Then let's do the math here. This is 64 divided by 232 equals 9.8 plus v squared divided by 2. So take a second here to do the math. We calculate velocity as 6.66 meters per second. So notice that as it goes up, potential energy decreases, potential energy increases, kinetic energy decreases, which is why the speed here is less than the starting speed of 8 meters per second. Now, what will happen if there is friction that comes into play? If there is friction, and let us say he loses a certain amount of joules due to friction. Let us say as he goes from here to here, he loses about 10 joules as heat due to friction. How do we set up the equation then? So all we have to do is to factor in the amount of energy lost. So I would say that mgh plus mv squared over 2 at position 1 minus the 10 joules becomes equal to mgh plus mv squared over 2 at position 2. And then you would substitute just as before and solve for the unknown. So if energy is lost due to friction, you just have to factor in that energy lost so that you can find out what is the final total energy and then solve for the unknown. I hope you have understood conservation of mechanical energy problem solving from this video. Until later.